Next, for our paper one topic, we're going to be talking about series and sequences. Okay, let's go up so we can look at our summary here. The first one we have is our arithmetic sequence, which is our linear pattern, where we have a constant difference between our pattern. So our pattern will be so the first one was A, the second one would be A plus 2, the third one would be A plus 2D. To find the difference between our pattern, we will say the second term minus the first term, or the third term minus the second term. So basically, we'll be saying the term before minus the term after minus the term before, depending on where the two terms are, but they must be consecutive. On the general equation for our arithmetic term says Tn is equals to A plus n minus 1D, where A is the first term, n is the term number, and D is then the constant difference. We also have our geometric sequence, which we call our exponential pattern. The geometric sequence is a sequence of numbers where there is a constant ratio between them. So it normally goes A, for the next one, A multiplied by R, which is the constant, the common ratio. And then the next one would be A R to the power of 2. So to get R, we would say the term after divided by the term before. And our general equation says Tn is equals to ARn minus 1, where A is our first term, and is our term number, R is our common ratio. Now, for the arithmetic sequence, we also have a series, which is then going to be the sum of all the terms in the arithmetic sequence. And it's given by the equation n over 2 multiplied by 2a plus n minus 1 multiplied by d, where n is a term number, a is the first term, and d will then be the difference. We can also have a geometric series, and we are able to sum it. We have two equations. You can use either one of them as long as here is not equals to 1. Then we have your convergent geometric series. So convergent just means that regardless of how many terms you add up together, the value seems to be going towards the same value, right? It doesn't change, even if I think in this case you can think about it as that the value as you go on is constantly getting so small that it doesn't make a big effect to the total sum. So for your geometric series to be convergent, your R value needs to be between negative 1 and 1, meaning that it needs to be then a ratio. So you can use the equation as infinity to give you A divided by 1 over R, where A is still our common ratio and A is the first letter. Now, for your metric exams, they sometimes can put more than one pattern, in this case sequence, in one. For example, they've given you this, which is a combination of your geometric pattern and your arithmetic pattern. So you can also find that. But the question sheet give you clues to see what's going on. So now, in terms of our series, we have a sigma notation that we can write them in, because we understand that the series are the sum of the terms. So the sigma notation is a very useful notation for giving the sum of a given term. So the way we read this is that this symbol means that the sum, and we're going to start where k is equals to 3, and then we're going to end where k is equals to 5 over there, and this is then the equation that we are using. So this is basically what we're doing is 3 multiplied by 3 plus 3 multiplied by 4 plus 3 multiplied by 5 and get the total sum. Now, if the sum is maybe series of equations, so maybe they gave you big numbers here. Maybe with k, you're going to start at 1, and then end up at, let's say, 100. And doing this would be too much work to do. So you would then look at your series and identify whether it is an arithmetic series or a geometric series. Then you use the correct equation here to then find what is the sum of those values, but also take into consideration where you start. What you can do is that you can make this your term 1, so you can form your new series, make this then your term 1, make this then your term 3, so that you know that n here would then be equals to 3. To see examples of this work being done, please head over to the Funda Manje YouTube channel. You can also find the link on our website and look at the past papers that have been done for both the D, EB, and O, and B.